list of achievements of Evina, I was greatly surprised, shocked that she is a really leader of astrochemistry in the world. She was a pioneer in astrochemistry some years ago, but now she is a real leader in this branch of science. She is well known over the world, and now she is acting as a president of International Astronomical Union, that's so leader of astronomy. I would like to give the floor to Evina, please. We will travel through universe now.
Okay. Thank you very much, Boris. Good morning, everybody. It's wonderful to be here in St. Petersburg and in Russia. This lecture is not going to be in Russian, but I hope that you all can all follow the English and also the slides. What I'm going to do, actually, in the next 40 minutes is take you through a tour of the universe. The first part will be to discuss where the elements that make actually also up us, where they do come from. There's a very nice poster there in the back, Space, it's called. So in the first half of my talk, I'm going to touch on that and explain a little bit what is in that poster. In the second part of the talk, I'm then going to delve into astrochemistry, namely what can we do with those elements in space, what kind of molecules can we actually form from that. Now, I'm standing here as an astronomer, as an astrochemist, but I'm actually also the president of the International Astronomical Union these 3 years. And as you all know, this is the year of the International Year of the Periodic Table of the chemical elements. But at the same time, we are also celebrating 100 years of the International Astronomical Union. And of course, the two go hand in hand because we study the formation of those elements and what they do in space. And so there's a clear link here with Mendeleyev's 150-year celebration. And I'll come back to that at the very end of my talk. Now, before I dive into the science, it is good to take sort of a little bit of a broader perspective. You've heard this morning talks about applications of elements in materials and material sciences and in the industry. But let's take sort of the bigger picture and the bigger question. Namely, where do we come from? What is our place in the universe? Are we alone? And these are questions that are not just of interest to scientists, but that actually fascinate humankind more generally. And you see that reflected, for example, in arts. Dutch painter Vincent van Gogh, he just had to paint the Starry Night. And you see that beautifully here with the Big Dipper. But you also can go to other parts of the world, for example, in Australia, the Aboriginals, and they also are fascinated by the beautiful Milky Way that they have above them, and they paint here the Milky Way dreaming, where you see the Pleiades with Orion on top. Now, where do we come from? Certainly, the elements that we have in our body were made in the Big Bang that created our universe, and then also subsequently through nuclear burning in various stars. And in fact, when you look at the periodic table in this way, you see only there in the bottom the man-made elements that you heard about yesterday during the plenary lectures. But the rest of the elements are made either in the Big Bang, such as hydrogen and helium, or they are made in stars. Some of them through nuclear fusion in small stars, some of them through nuclear fusion in large stars, big stars, and then also supernovae explosions. There we get to temperatures that we can really go up to some of the highest elements.